Okay, students. So we have come back with the slides where we have left our lecture. We were discussing with the center of sums where we are going to deal with one example. So here you can see that we have two membership functions. One is the membership function, or we can say that the fuzzy set, that is the C1. C1, this is a one fuzzy set, and obviously we have one kind of membership function which is related to this C1 fuzzy set, and we have another membership function. This is A2. This is the kind of degree of membership which is related to the next fuzzy set, that is C2. So now the question is how we can evaluate the center of sums. So if we closely observe that we are basically need to identify first the mid of each membership area. So if we go through this, so we know that any kind of need value of any kind of large area, so we need to follow the summation of the starting point and the summation of and the ending point, and obviously whole divided by 2. So here the process is quite tricky. So what that particular process says that you first try to concentrate these bracket position. Bracket involves a kind of summation of two values. So what are these values? This is, you can see that this is the whole area where basically these membership function, resides. So this is the highest value 8 minus 1. This is the lowest value of this, and plus this is the mid of the position, or we can say this is the area where we are having the maximum membership value, that is the plateau region. So automatically the highest value of this maximum membership area is 7, minus we can have the lowest value of this maximum membership value, that is 3. So automatically now it is very much clear to us that what denotes this 8 minus 1 and what denotes this 7 minus 3. Now we need to find out the midpoint of this whole area. So automatically divided by half. That is why this 1 by 2 is multiplied by this. And we have one multiplying factor which is 0.5, which is nothing but the highest membership value. So this expression gives us the value of 2.75. So you first keep this particular value aside. Now coming to the second fuzzy set, that is for C2. So you can see that if this is a kind of second fuzzy set, here this is denoted as A2. So basically here you can see that like the first one, this is the stretch of the second membership function, which is the starting value is 3 and the ending value is 9. So automatically 9 minus 3 plus this is the area where this particular membership value has the highest degree of membership. So automatically this is 8 minus 4, and we need to find out the mid of this particular regions 1 by 2 and multiplied by the highest membership value, which is nothing but 0.3. So this expression gives us a value of 1.5. Now, what is the center of area of C1? What is the center of area of C1? If you can see that if this is the fuzzy set C1 and C2, so here this C1 is nothing but the fuzzy set of A1 membership function, and here C2 is nothing but the fuzzy set of A2 membership function. So what is the C1? C1 is nothing but the 7 plus 3 divided by 2. That means the highest membership plateau region, and the center of area of C2 is nothing but 8 plus 4 divided by 2. That is the highest membership plateau divided by 2. That means the range of this plateau. So if this is the center of area of C1 and this is the center of area C2, then what could be the defuzzified value? Defuzzified value is nothing but the center point multiplied by its membership value plus center point next and the membership value, I mean multiplied by the second membership function. I'm sorry, here the center of area of C2 is not being calculated. You can, if you can multiply, I mean plus, sum this 8 plus 4, it will give you 12 divided by 2, it will give you the 6. This 6 is coming from here, whole divided by the sum of these two membership functions, that I mean values, that means 2.75 plus 1.5. So whole this amount of process will give you the one particular value, one particular crisp value. You can see 5 point, which is 5.35, and this is your center of sums. So this is one defuzzification process which mm, may quite seem which may seem quite tricky, some quite some complicated, but you may wonder how this particular defuzzification technique gives you the faster defuzzification result. Now coming to the next one, this is the center of the largest area. It is a kind of concept that if you have this kind of variable membership functions of one fuzzy set, then you need to find out the most largest area, and depending on that largest area, you need to find out what is the center of that largest area. So this, if the fuzzy output set has at least two convex subregions, so defuzzify the largest area using centroid. That means you have this kind of gradually increasing kind of membership function. If it is so, if this part is not present, then it is quite easier for you because you have only one fuzzy set which is having this kind of variable membership function. But suddenly after this point, you may find that this particular grade of membership is falling down rapidly, but it is not coming to the zero, and it will have again one rising this kind of situation. So if you have this kind of, I mean, two or more convex subregion, then you need to defuzzify the largest area using the centroid method, and we know that the formula of centroid. So basically, applying the values of this particular largest area, you can have the value centroid which may situate at this particular point. Now, first or last of the maxima, this is quite interesting. That means if you have again different kind of membership functions, and obviously this membership functions are overlapped each other, then you need to find out the particular membership function which is having the maximum degree of membership. So if you can see that this is a kind of membership function in the graph, on the graph, and obviously until and unless it is coming to an end, again the second membership function is you're going to start, and it will have a kind of triangular membership function, and it will have an overlap region as well. So basically, when we have these kind of two membership functions, we need to find out which membership function is having the highest membership degree. So basically, it is the triangular membership function. So you need to find out the, I mean, the maximum of this particular membership function. That means the mid value between these area of interest. So it can be seen that there is a first or last of maxima. That means first of last of maxima, if you can have these two values of the any kind of, I mean, first or last of maxima, what is the maximum point, then you can determine the centroid. But here, as this particular membership function is a triangular membership function, you can see that there is only one particular point where it is having the maximum membership function. So automatically the defuzzification process becomes very easy. You are going to only note down the value at which the particular, I mean, membership function is attaining the maximum degree of membership. So, what would be the case if we have a plateau on this degree of membership value of 1? So this is a kind of case you can see that we can have, I mean, this kind of membership function of any kind of fuzzy set. Then also we need to first find out what is the highest degree of membership, and what is the, I mean, what was the region of this highest membership function. So if I now denote that this is the region of interest which is having the highest degree of membership value, which is here zero point 0.8, not 1, mind it, not 1 but zero point 0.8. So basically if we draw a vertical lines from these 2 points, that is the first of maxima and the last of maxima, then you can have two distinct points, one is 4, another is 8, and then you can decide that the mean of maxima, which is 6. So 6 will be the answer. So basically here you need to know that this kind of differentiation technique deals with the maxima. So whether it is asking for first of maxima, whether it is asking for last of maxima, whether it is asking for mean of maxima. So basically this depends on the researcher, this depends on the developer, who basically is aware that our information, I mean our information of interest resides where, whether it is near the first of maxima, if whether it is near of last of maxima, or it is a mean of maxima, but we can do either of any three. So we have reached to the end of this lecture. So this is all about today's lecture, which is the defuzzification techniques, the 7 defuzzification techniques we have covered, and I am hoping to this particular goal or aim that you may understand the lecture. If you have any queries, and then do ask me on Google Classroom regarding this particular video lecture, and also we will be ready to solve some kind of assignments and some kind of test questions based on these lectures. And also I'm going to upload one Google form which involves some kind of questions based on today's lecture. You need to again solve it, you need to again submit it, and stay safe finally, and also keep watching my lecture so that we can, you know, move forward with our self-computing class and self-computing syllabus as well. Thank you very much for listening my lecture.